What's going on, everyone? Mr. Garcia here. Got a video over proportions, rates, and conversions. In this video, I'm not going through every question. I'll go through numbers 1 through 4, and then number 6, and then number 8. If you have questions about number 5 or number 7, please find me, shoot me an email, and I'd be more than happy to help as well. Off the bat, unit rates are very, very important for proportions. Think of it as when you're comparing two items, you're looking at the second item in terms of one. So the good news is it's a lot of dividing. The first quantity by the second quantity. When we say the second quantity, it can be very abstract of what do you want the first or the second to be. For example, in number 1, you have a package with 12 bottles for $30. What's the unit cost per bottle? That typically means in this case, how much does one bottle cost? 12 of them cost $30. So how much does one of them cost? Some people may do a conversion chart. Stuff like number 1 is a little bit easier, where you may not need a conversion chart. It's just good to organize your information. For example, 12 bottles is $30. How much is one bottle? So there's a couple different ways to approach these. Conversion charts are really just fractions and proportions. You can do a bunch of different things. For example, you always want to multiply or divide. So if you have 12, if you did 12 divided by 12, that gets you 1. So if I do 30 divided by 12, well, that's a multiplication. That would get you, in this case, 2.5. Conversion charts lets you scale up or scale down. You can also go across as well, by the way. For example, 12 times something gets you 30. I'm not really sure what that is, but if you do 30 divided by 12, which in this case would be 2.5, you could then multiply the 1 by 2.5. Proportions let you do a bunch of different things, and so that's a really good news there about that. Same thing for number 2. If you want to set up a chart, you definitely can, where you have the amount of pens being compared to the amount it costs. So we say we have 6 pens for $4.50. Ooh, what is the cost in dollars of P pens? So what is the cost? And then the amount of pens we have is just P. So same idea here. And I think this is where it's kind of nice when you think about how we do conversions. And this is a very good TSI fact of understanding how we did it with numbers, but then now trying to do it with simply just variables. So for example, same idea here. How much is it just for 1 pen? Well, if I look at my conversion from this way, 450 divided by 6 is going to be, in that case, 0.75. So 6 times 0.75 gives me 450. How many was it cost in dollars of P pens? Well, it's a proportion. So we can do P times 0.75 to get just 0.75 P. Abstractness with variables is so important. But with proportions, when we kind of set up our equations or our fractions, these can be set up so many different ways thanks to your conversion chart. For example, we know in this map we have 1 inch that equals 9 miles, which proportions can be used to find the number of miles that's represented by 4 inches. So the key note here with proportions is find out the stuff that's equal to each other. We're saying, for example, and I'll show you a couple different proportions we can write. We know that 1 inch is equivalent to 9 miles. We are comparing those two quantities and we're saying, hey, those two are going to be the same for us. Obviously, it's a map, so fun stuff there. How many miles, or I guess they use M in this case, is it for 4 inches? So notice I compared, if I said 1 inch over 9 miles, I'll say inch over n miles. I could also say, if you knew that 1 inch is 9 miles, maybe we flip it. In that case, I would then say m miles over 4 inches. You'll notice that either way, you'll still have the same type of quantity. Same idea here. This one might be a little more common as well. Maybe just compare the quantities with each other. For example, if I had 1 inch, and that's going to get you 9 miles, how many would 4 inches get you in M amount of miles? Either one is fine. And this question specifically, it looks like it's going to be answer choice C. And it looks like they kind of set up the equation that we did in the first one. 1 inch over 9 miles, and then 4 inches over N miles. Same idea for number 4, except that now, we got Z plus 4. That's interesting. But again, let's just set your proportion up. Let's do it kind of similar to number 3, because we have different options here. Either one is fine. I'm just picking the first option because why not? Okay, 3 apples for every 6 oranges. And now we want to see if you have 14 oranges and you have Z plus 4 apples. Interesting. What must the value of Z be such that it's the same ratio? As in, hey, what should the value of Z here be if this is truly proportion? Couple different ways to approach this. You can solve these typically by cross multiplication. That's not the only way. If you want to view this as like a fraction, 1/2, and you want this part to work out to be 1/2 as well, you can. That's just understanding proportions in general. So if this is 1/2 and that's 14, that means this part kind of has to be 7, because 7 over 14 is 1/2, which means that's 3. That's more of a logical sense. If you're like, Ms. Garcia, that made no sense, just stick with cross multiplication. That's just a good rule. You guys like the cross multiplying, the butterfly method, that stuff. When we cross multiply, we're essentially trying to get rid of these fractions. So we're doing 3 times 14, and we're doing 6 times all of that Z plus 4. Now, at this point, it just becomes a calculated question where we can just do some math and work and solve it. 3 times 14 is 42. Be sure to distribute that 6. So 6Z plus 24. Bring down your little railroad track there. So subtract 24. And we got no space. 42 minus 24 is 18. 6Z is the only thing that's left on that side. So we can divide by 6 to get a value of 3. And again, if we want to, plug in 3 again. 3 plus 4 is 7. 7 divided by 14 is 0.5. 3 divided by 6 is also 0.5. That's what it means to be a proportion in the same ratio. It's literally the same number on both sides. So there's good news there for that. Last one for this video, we talk about number 6 and number 8. Number 5 and 6 are a little bit easier. That's why I didn't want to talk about it in this video. Number 6 is so weird. So again, still very abstract. And this one especially is super abstract. So number 6, you have a car that's traveling at a constant speed, and it covers a D amount of miles in H hours. Which expression represents the distance the car travels in 5 hours? Oof, that's a fun one. So when we look at this last statement here, what expression represents the distance the car travels in 5 hours? Well, if you're trying to represent distance, right, distance, well, if you don't know this, it's the speed that you're going, the rate, times the amount of time you're taking. Kind of makes sense. So in this case, if we knew some type of speed and we can multiply that by 5, that could tell me how far or the distance we're traveling. They don't really tell you much in this case. All they tell you that you're traveling at a constant speed and you're covering a certain amount of miles, a certain amount of hours. So this is a two-parter. We need to represent our rate or your time as D and H. Now, instead of time, I'm going to use H. Duh. And rate, you can say speed or R. It doesn't really matter here. So in this case, if I asked you, Distance equals rate times time, which is h for us. Let's solve for r. You would say, well, you want r by itself, so let's divide by h. So the rate that we're traveling is some distance over the amount of time, which is hours. So we're traveling at this speed of some abstract distance over hours. Cool. Go back to the original question. What is the distance? Well, your distance is that rate we just said, d over h, times, in this case, 5 hours. Oh, my bad. Should have been h, times 5. So for us, that matches up with answer choice A. So very, very abstract. I mean, there's only one number here and a bunch of letters. But it's just trying to understand distance equals rate times time and two different quantities, essentially. All right, number 8. Last question for this video. Excuse me. A runner is completing 9 miles in 1.5 hours. At this constant rate, how many miles would the runner run in T amount of minutes? Couple different things. I see different units. Hours, but they want it in minutes. So 1.5 hours. Well, we know 60 minutes is 1 hour. Therefore, half of 60 minutes is 30 minutes. So 1.5 hours is going to be 90 minutes. We know that fact. So even though I'm saying 9 miles is equivalent to 1.5 hours, we could technically say 9 miles is equivalent to 90 minutes. Now, we want to figure out the amount of T amount of minutes, okay? So I'm going to say T amount of minutes. Don't know what that is. We're going to figure it out in a second. Well, let's figure out how many is in 1 minute. How far did we travel in 1 minute? Not very far, probably. So let's do 9 divided by 90. So in 1 minute, we traveled 0.1 miles. Sure, good progress. Why is that important? That means when you scale up the amount of minutes, so when, for example, if you multiply by 90, you multiply this by 90 and get 9 miles. We're multiplying by 0.1 every single time. So if I asked you how far you're traveling in T minutes, that means 1 minute, 90 minutes, 45 minutes. You would take the amount of time and multiply it by 0.1. That unit rate was that 0.1. Your expression of 1 was 1 minute. I used this as the 1 because they were asking about it in amount of minutes. Thank you for watching the video. If you have any questions, be sure to let me know. If not, thanks so much for watching. Hope you have a great rest of your day. And as always, go Mavericks.